So lately I've been trying to charge up a big capacitor banks with mains voltage. And of course this is quite a problem because these big electrolytic capacitors have pretty much no impedance, and the current in rushing into them is enormous. It can be even in hundreds of amps, even thousands of amps, which will easily trip any breaker. And this is quite a problem because most switching power supplies are using these big capacitors to smooth out the voltage. As you can see, these two capacitors in this power supply. And usually what you do is you introduce some resistance over here in series with the capacitor. This way you limit the inrush current and the capacitor can easily charge. But this is of course a problem because it is quite inefficient. If you are powering anything from the power supply, there will be a voltage drop across this resistor. So usually we charge up the capacitor and then after some time we close a switch, bypassing the resistor, and we can power the rest of the circuit. So this is my setup for preventing a high inrush current from tripping any breaker. Here are two quite large electrolytic capacitors, each one rated 450 volts at 10,000 microfarads, so that's quite a capacitance. Here's a bridge rectifier. Here are the NTC thermistors, which limit the current. They are not just resistors, they are NTC, which means negative temperature coefficient. And these basically have a very high resistance once they are cold, but their resistance drops dramatically once they are getting hot. So this basically kind of regulates the voltage drop across the NTCs so that they do not blow up. And they are very commonly used in switch mode power supplies. With this DC voltmeter I will be measuring the voltage across the capacitors, and I'm scoping across 0.1 ohm resistor in series so that I can measure the inrush current. On this oscilloscope I set it that there is 20 amps per division, so each division is 20 amps. And we are triggering on 20 amps, so once the current is above 20 amps we will see it on the oscilloscope. And I will set the voltage with this variac and we'll see what we're gonna measure. So the variac is on. Let's crank the voltage up. Let's put around 200 volts for starters, just lower voltage. So there's 200 volts, and let's plug it in. So of course this is very dangerous, and please never ever do this at home or anywhere else. So, okay, that's interesting. We can't see anything on the scope, which means that the current was not above 20 amps. Oh, that's interesting. And the voltage on the capacitors is 266 volts. Alright, let's try it again. Let's disconnect everything. Let's discharge our capacitors. I'm using this 500 watt lamp to discharge the capacitors, and the lamp of course gets very bright, as you will see in a moment. Alright, so the capacitors are discharged. Let's try a higher voltage. You know what, let's go all the way up to the mains voltage. So we are going for 240 volts, 230, 240. So I also set the oscilloscope for 10 amps per division so we see it a bit better. So there's 10 amp per division right now. Alright, and of course never do this, as this is very dodgy. And let's plug it in. Alright, so that's quite a nice waveform. Let's disconnect it again, just for safety reasons of course. And of course never forget to discharge the capacitors. Believe me or not, but right now the capacitors charged for 330 volts. That's enough to kill you. If you touch these, you can actually die. So always discharge your capacitors and make sure they are discharged before any handling. So this is the waveform. So you can see it is, let me just get it straight. Alright, so here we got 10 amps per division, so you can see that the highest current peak was around 38 amps. And even after, let's say, about 10 periods, how many periods? Well, let's say a lot. After a lot of periods, we still got the current flowing almost 30 amps. So the inrush current to these capacitors is quite large, and the NTC thermistors are actually quite hot. I mean, they are not hot to touch, but they are about 50 degrees, I would say, in just such a small time. So yeah, this was the inrush current into these big capacitors. You can see that the current is not going lower and lower and lower as you might expect. It's actually the third peak over here is actually higher than the first one, which is weird since the capacitor should be charging. But yeah, that's because of the NTC thermistors losing their resistance, so they allow more current flowing into. So this time let's try it once more. This time without any variac, like setting the voltage with variac. That's a child's play. Let's go directly with the mains voltage. We'll see if the current will change anyhow. It's even possible that the variac was actually limiting the current. We'll see. So again, 10 amps per division. Let's hope we will not trip any breakers. So let's go. Alright, 325 volts, and again the current waveform is pretty much the same. So yeah, that is the inrush current into 20,000 microfarad capacitor bank, and I will be using a similar bank inside this Tesla coil over here. So that's why I needed to limit the inrush current. Of course, this circuit is not complete. We will need something to bypass the NTC thermistors, and I'm using just a relay with a timing circuit to bypass it. So I hope it'll work, and thank you for watching.